Well, hey, Algebra, Mr. Erickson here. We are on to Friday 5-8 here. And we're just going to kind of review how to graph quadratic functions. And so something we've done before, I know it's been a while, but it'll be something that'll be important just in your future math career. So we're not going to quiz over this, kind of like lesson 5 on Wednesday. We're just going to just kind of review it because it will be something that'll be good just to kind of hit again here before we get to our final assessment next week. All right, so so just kind of several things involved with graphing. The main idea here is to graph starting by identifying, remember that x-axis is symmetry. The one thing you really need to memorize is that x equals negative b over 2a. And there it is right there, axis of symmetry, x equals negative b over 2a. And so that's what you always pretty much are going to start with, and you're going to want to memorize really that formula just to know what to start with. But once you get that, we can then center our function table or our t-chart, with the vertex being smack dab in the middle. And then we would then plug in the values of x around it. So just to kind of jump down here for a second, you'll notice here on this xy function table, our x equals negative b over 2a, our vertex point. Once again, that's in the center of the parabola, in the center of kind of that U, or upside down kind of, N shape, but that upside, that typically right side up U shape. The vertex is right in the middle at that lowest point. And so everything is symmetric around that point, right? If I take my pen here and I just draw kind of a parabola here, it goes up like that, goes up like that. Once again, if you notice, I started right here from what we call the vertex. So, but on either side of the vertex, I could draw kind of a line of symmetry here. It's the same, right? If I'm up at like a height of, say, like, I don't know, whatever this is over here, notice I jump right across the same distance to the other side. We're at that same height. So you're symmetric on either side. And so, so basically you'd want to start here with that as the middle of the function chart there, function table. And then you'd want to pick values on either side of it. Okay, so we'll look at some more examples of that, but that's really the bottom line here of having success today, is doing that. So otherwise, we'll just kind of jump on here a little bit. We won't cover everything that's on here. Just kind of remember up here, the axis of symmetry. Remember, kind of as we already alluded to a little bit there, that's the x-coordinate of the vertex, right? Same thing. So whatever you find this to be, that axis of symmetry, that's going to be whatever the x is here for your x comma y for the vertex. Okay, and then to find the corresponding y value, all you do is substitute that x into the function, and whatever y ends up being equal to, whatever number that is, that of course would go for the y coordinate in the vertex. Okay. All right, solving, that's just kind of review from the discriminant and things from last week. We won't really use that a whole lot today. So to graph an equation, once again, first step we talked about is find that axis of symmetry, x equals negative b over 2a. Now remember to identify a, b, and c, kind of like the quadratic formula. Everything needs to be on the same side. It typically, I think, will already for you, but just keep in mind that that would be a requirement here. We need everything on the same side to figure out what is a, b, and c. Keeping in mind that a negative number is a negative number. So b could be negative, c could be negative, even a could be negative if there's a negative sign in front of it. All right, then you substitute this value into the function, evaluate for y, kind of like what we talked about above. That would give you the vertex, right, the x comma y, and that number would go here. Let's say we got 2 to be our vertex. We plugged it in, we got 5, for example, or whatever. That y value would go over there, okay? And once again, that's in the middle of our t-chart. So you would make a function table there and use the fact, of course, that parabolas are symmetric to determine the other points. So if this was a 2, I'd probably put a 1 and a 0 there on that side, and maybe a 3 and a 4 on that side. And then once again, we've got that middle point there as the vertex, and the other points there would be matching, symmetric on either side, kind of like we have here. You go 1 this way, it's a 3, 1 that way, it's a 1, so on and so forth. And then you would just evaluate those, right? So plug 1 into the function, what do you get? You put that number there. You plug 0 into the function, what do you get? You put that number there, kind of thing. So that's kind of the idea there. So to identify key features on the graph, here's just kind of a guide. I know on Math Excel, they will ask you to identify just a lot of little things, a lot of features just on different parts of the graph. And so just kind of, this is a guide really that you can use just to refer back to as you're working on that. So first of all, like the vertex here. So the vertex, once again, we know we calculate that axis of symmetry first, plug in that x into the function, get the corresponding output, or y. Then you have your vertex, which is that x comma y. That would be the vertex. If you've done that, you actually already have the line of symmetry or the axis of symmetry right in front of you. Remember, that was that part that was the x equals negative b over 2a. Make sure you write that as x equals whatever number. Okay, so that's how you write your answer. Say x equals 2. It would have been above in that little example I did above. All right, of course, when the vertex was 2 comma 5, for example. So. All right, last one here, or not last one, third one, minimum and maximum value. So remember the y-coordinate of the vertex, if we're doing our little example up there, it was the 5. That is either that minimum or maximum value. Now to figure that out, you need to figure out, does the parabola open up? If it is, it's the minimum value. If it opens down, it's the maximum value. So for example, opening up, it'd be like this. Notice the vertex is the lowest point. If it opens down, the vertex is the highest or maximum point. So just kind of keep that in mind. And to figure that out, of course, you look and say, what is the sign of A? Is A positive, or do you have A negative, right? If A is positive, it opens up. If A is negative, it opens down. Okay. Fourth here, the X-Intercept. So this would be, of course, a couple ways you could do it. If you have the graph in front of you, you could just visually, in many cases, not all of them, but visually identify what they are. Remember, those are where the function basically hits or intersects the x-axis. Could be 2 times, could be just 1 time. It might be not at all if it's kind of floating up in midair, and it doesn't actually go through the x-axis. But if you're able to identify what those points are, if it's clearly the integer 1 and the integer -3 or something, then you could, not much work to do there. But otherwise, the harder way or the more involved way, which is what we typically have to do, is to substitute 0 for the y. So you basically set the function equal to 0, basically make it into a quadratic equation. So if we had like y, for example, is equal to x squared minus 3x plus 4 or something like that, just throwing an example out of just off the top of my head here. Instead of y equals, we would want to change that here to make it 0 is equal to. Right, so I put a 0 there, and then I would basically solve that equation, figure out what is x equal to. Could be, once again, 0, 1, or 2 things. All right, and then the y-intercept, of course, there, lastly, is something else they might ask you to find. So for the y-intercept, once again, you could visually identify it. Actually, might be a little bit easier on many of these to do that if you have the graph in front of you, as long as it's an integer. If it's kind of between a couple numbers, sometimes you might just be able to say, hey, it's between 2 and 3, or sometimes, you might have to actually calculate it because we don't actually know what that number is between 2 and 3. Just depends on kind of what they're asking for. But an easy way to find this one actually is just by looking at whatever the c value is. So if you have the equation in front of you, of course, the technical way to do it is to substitute 0 in for the x's and then find out what the y would be equal to. But if you think about putting zeros in for the x's, if I look at my example up there, I had the 0 equals x squared minus 3x plus 4. If I put zeros into those spots, they're just going to disappear. And so your y-intercept is actually kind of like slope-intercept form, how it was y equals mx plus b. And b was that number that you saw visually right there was your y-intercept. It's kind of the same situation here. 4 would be our y-intercept because it's the number that's by itself that's left once you get rid of all the x's and just kind of drop those terms out. So you would have the 0, of course, would be gone there. You'd have y equals 4 would be your y-intercept there. So it's always whatever the c value is, as long as it's in that form where you can identify a, b, and c. All right, just an example here. We'll kind of go through this pretty quick, and then there's some videos down there if you want more information, more examples. But so for this quadratic equation, notice it's already in that form where we have f of x, so that's the same as saying y equals negative x squared plus 4x plus 4. And we're going to graph it and identify a bunch of these things. First of all, we need to make sure we know what a, b, and c are. So a is -1 because of the negative sign there, +4 and +4. Here, I think you don't necessarily always have to do this, but if you wanted to figure out the discriminant, we can do that. B squared minus 4ac, just like we did last week, ends up being 32. That's a +1, so we're going to expect 2 solutions to the graph, which means we'll have 2 x-intercepts, 2 places where the parabola crosses the x-axis. Since a is -1, it's negative, so the parabola will open downwards. So just to kind of make a really just quick sketch of what we're probably predicting here. It looks like the discriminant's positive, so we're going to have to hit the x-axis twice, and because it opens downward, the vertex is going to have to be somewhere here above the x-axis, and it's going to have to go down kind of like that. Once again, where there'd be two solutions, two spots where it hits the x-axis, and also it opens downward because a is negative. So that also means that the vertex, just kind of as a spoiler alert here, will be the maximum value, right? The highest point that we come to. All right, so from here you can start to identify everything. So for part A, to find the vertex, you first need to find the axis of symmetry. X equals -b over 2a. You end up getting x is equal to 2. So, which I guess that's, of course, going to end up being our axis of symmetry for part B. But for now, of course, that means you have 2 comma something for your vertex. And then we would plug in 2 here into the function, like what we did there. And we end up seeing that y is 8. So that means that 8 is going to be that output, the corresponding output here for when x is equal to 2. So your vertex is 2 comma 8. All right, y value from the vertex there is 8 there. So we, of course, figured out that it was 8. So that's our y value. Since it opens down, a is a negative number. Put these two facts together. You know it's not a minimum. You know that y equals 8 is our maximum value, the maximum height that we can get to on our parabola. All right, from there, you'd complete the function table. Remember, the highlighted part here, what's important, make sure you put the vertex in the center of the table. So we have our 2 comma 8 right there, right in the middle of our table. We're centering it around x equals 2, which means we're going to do 0 and 1 below it, 3 and 4 above it. And then we'll plug in those values. That's where it takes a little bit of work, just plugging those in. But once you get those, you end up getting kind of all these y values over there. And then I think lastly, we just have our intercepts here. So we happen to have on there, notice we did plug in x equals 0, which means our y-intercept would have to be 4. So y-intercept is 0 comma 4. The other way you could have figured that out was looking up here. Remember, because this is a 4 right there, the number by itself, if you were to cross off the terms with x, you would have y is equal to 4. So that's another way to figure out the y-intercept. Lastly, of course, if you are looking at the graph, which we have a Desmos graph here of this function, notice the y-intercept, the y-axis is right here, of course, and it went through right at 4. It was right on the dot, so we can say, all right, y is equal to 4 is our y-intercept. All right, from there, we can then look at our x-intercepts. Here's where they might just ask you between what two values. So like here, it's 5 would be right about there. So it's close to 5, but not quite. So we would say like between 4 and 5. And once again, I think MathXL will let you, I believe, do that for some of them. And then the other one here, there's 1. It gets close, but not right. I know it's not quite right at 1. I know it looks close, but don't call it exact there. We would say then for the other one between -1 and 0. Okay, so you might be able to get away with doing that. Once again, recognizing it's not -1, it's some number between 0 and -1. Otherwise, to do it exactly, that's where we get into our solving techniques we learned last week. Typically, probably being quadratic formula on a lot of these. If it's not like a certain number that you can see on the graph, it means it's probably some, irrational number. They're kind of between 0 and -1. So probably gonna have to use the quadratic formula or complete the square potentially. So to do that, you would just solve it. Of course, we know what a, b, and c are. Let's plug it into the quadratic formula. You get 2 plus or minus square root of 5. So that means your x-intercepts are -2 or 2 minus square root of 5, comma 0, and 2 plus square root of 5, comma 0. So that would be an example just to walk through one. Otherwise, if you guys have questions, don't hesitate to reach out, and hope you guys have a great week.